You recently did equations with like terms on one side, and we're now going to work on equations with variables on both sides. So this is going to look kind of similar to the previous, but there's a very big difference. I have a 7x on the left-hand side of the equal sign, and I have a 10x on the right-hand side of the equal sign. If they were on the same side of the equal sign, then we could combine them like terms. But they're not. So I have to make a decision. Either the 7x has to travel over there, or the 10x has to travel over here. Either one is fine. Since my goal is to get x by itself, I want to get the x away from the minus 15, so I'm going to choose to move the 7x to the other side. To move a positive 7x, and remember there's a positive sign there, I subtract 7x, I subtract 7x. Now when I do that, if I look at the left-hand side, these add to 0, or subtract to 0, so I'm left with a minus 15, and a 10x minus 7x is a 3x. This is good news because I used to have an x on the left and x on the right. Since my goal is to get x by itself, I'm glad that I only have one x in this problem now. And in fact, that x has a 3 attached to it by multiplication, so what the heck, let's divide by 3. X equals -5. Kaboom, I'm done. But notice that the combining of those two was different than what we did when we were combining like terms on the same side. Let's move to this next one. I spot some distribution. So I'm going to go ahead and do that. -5x minus 15 minus 5 equals 10x. I've got a lot going on right now. I have a -15 and a -5, which even though they're just regular old numbers, they're like terms which could be combined. So I'm going to do that first. I'm going to have -5x minus 20 equals 10x. Keep in mind my goal is to get x by itself. If I have some x's on the right and some x's on the left, that's not going to work. So I either have to move this -5x over there or this 10x over here. Well, I don't want to bring more stuff over by the -20. X wants to get away from the other stuff. So I add 5x to make this guy move. I have to do the same thing to both sides. And now I get a -20 equals 15x. To get x by itself, I divide each side by 15. And I can reduce this, or I can call it, I can go to the calculator and divide it. Whatever way you do it, you're going to get something like this. It's going to be a negative, and it's going to be something like -1 1/3. Maybe you get a -4/3. That's the same thing. Or maybe you get a -1.333. That's also the same thing. All right, we're going to do two a little bit squirrelier ones down here. You see number 3's got a fraction. Shriek with terror. My goal is to get the x by itself, and I have some x's over here and I have some x's over here. I also have some numbers on both sides. So I'm going to make this decision. I'm going to move this 8 over there by subtracting 8 from both sides. When I do that, on this side I have a 2/3 x, and on that side 11/3 x minus 12. Okay, so it's a little bit awkward. I have some x's over here and some x's over here. That means I need to move this x over to the other side. I don't see a sign on it, so I know it's positive. To get rid of a positive 11/3 x, I subtract 11/3 x. That means on my right-hand side, the only thing remaining is a -12. And now over here, 2/3 minus 11/3 is -9/3 x. If you need to learn how to use your calculator to combine those fractions, that's probably a good idea, and you could ask in class. By the way, negative 9/3, a 9 over 3 is, or a 9 divided by 3 is a negative 3. So I can rewrite this as negative 3x. So this has been pretty clunky up here, but by the time you get to this spot, it's not so bad. If my goal is to get x by itself, the negative 3 is attached by multiplication, I do division, and x equals 4. Now I knew that problem was going to be pretty rough. It's because of the awkwardness of the fractions. All right, let's do one more and be done with this. So I'm going to center this a little bit better. In this problem, the first thing I see is some distribution, so I'm going to do that first. Notice that I'm not doing anything else to any part of this problem. I'm just recopying. Now I also see some like terms. These are on the same side of the equal sign, so I'm just going to combine them. I'm going to get an 8x minus 6. Notice that everything else is just being recopied as neatly as possible. I have some x's over here and some x's over here. I need to choose a side. I'm going to make the minus 2x come over to this side. How do I move a minus 2x to the other side? I add, or I do the opposite. Notice that everything else is still staying the same. 10x minus 6 equals 4. My goal is to get x by itself. I need to move the minus 6. I do that by doing the opposite. I add 6 to each side. 10x equals 10. The x is almost by itself. 10 is attached by multiplication. I do division. X equals 1. All right, you'll notice that our equations have gotten a lot more complicated. And today, when you have variables on both sides, you had to make a decision. Do I want to send this variable over to that side, or did I want to send this variable over to that side? No matter which one you choose, as long as you do the steps correctly, you will get a correct answer, even though your work might look different than somebody else's.